Welcome back everyone. In this video we're going to solve numericals related to distance formula. Let's get started. Let us jump into some numerical problems. Find the distance between the pair of points. Number 1, 2, 3 and 4, 2. So the given points are, let's consider them to be P and Q. So here x1 is 2, y1 is 3, x2 is 4, y2 is 2. So we have the distance PQ is equal to square root of x2 minus x1 whole thing square plus y2 minus y1 whole thing square, which is nothing but our formula. Then we substitute the values of these and we get this. Solving this, 4 minus 2 is 2, 2 squared 4, and 2 minus 3 is minus 1, squared is 1. 4 plus 1 equals 5. So the answer is square root 5. It is important to write units because distance has unit. Now we don't know what the unit is, so we'll simply write units. Let us see one more numerical problem. This one slightly different from the previous. Find the value of x for which the distance between the points P and Q is 10 units. Now the given points are P 4, minus 5, Q 12, x. By question, we know that PQ is equal to 10 units. So it looks something like this. This is P, this is Q. The coordinates are 4, minus 5, that is x1, y1, 12, x, that is x2, y2. And the distance PQ is 10. So substituting in the formula, we get 12 minus 4 plus x plus 5 squared and whole thing under root is equal to 10. Now 12 minus 4 is 8, x plus 5 remains as x plus 5, 8 square is 64, taken this side becomes minus 64, so x plus 5 whole thing square is equal to 36. Now 36 we know that it is equal to 6 squared. So taking square root both sides, we get x plus 5 is equal to plus minus 6. So x plus 5 is equal to 6 or x plus 5 equals minus 6. Hence x is equal to 1, 5 goes this side, 6 minus 5 equals 1, and 5 goes this side, minus 6 minus 5 minus 6 minus 5 is 11. Let us now look at a very interesting example. If the points A and B are on the circle with center O, find the value of x. So it will look something like this. This is a circle with center O. The coordinates are given to be 2, 3. And A and B lie on the circumference of the circle with coordinates 4, 3, x, 5 respectively. Now, it is to be understood that we cannot solve this problem with the previous method because here the distance is not given. So we'll have to find some other equation. Now, we know that OA and OB are radii of the same circle, and we all know that radii of a circle is always same. So OA equals OB. Now, taking OA and substituting in the distance formula, we get this. Similarly, taking OB and substituting the values, we get this. So solving this, 4 minus 2 is 2. 2 square 4, 3 minus 3 is 0, 0 square is 0. X minus 2 whole thing square cannot be solved yet. 5 minus 3 is 2 whole thing square is 4. Taking square both sides to eliminate the square root, we get 4 x minus 2 whole thing squared plus 4. Now 4 and 4 can be cancelled both sides. X minus 2 whole thing squared equals 0. X minus 2 equals 0. Taking square root both sides, if we bring this 2 here, we simply get x equals 2. Let us look at one more interesting question. Show that the points AA minus A comma minus A and minus root 3A are the vertices of an equilateral triangle. Now, we know that an equilateral triangle has all three sides equal. So if we take these points as A, B and C, then we can find AB, BC, CA, and if we can prove that AB equals BC equals AC, that means all three sides are equal, then we can easily prove that these are nothing but vertices of an equilateral triangle. Also find its area. Now, AB, if you substitute x1, x2, y1, y2, you get this. Now on solving, we get minus A is 4A square and minus A square is 4A square. 4A square plus 4A square is 8A square. On solving, we know that square root of 8 is nothing but square root of 2 square into 2. 2 square will come out, so you'll be left with 2 root 2. These are nothing but the basics, so I hope you know the basics. BC is similarly equal to 2 root 2A. AC is also equal to 2 root 2A. From these three, we see that AB equals BC equals AC. That means all three sides are equal. The given points are vertices of an equilateral triangle. Now, area of triangle ABC is square root 3 over 4 into side square. So, substituting, we get square root 3 by 4, and side we can choose any one of them since all are equal. So 2 root 2A whole thing square. On solving, we get it to be 2 square root 3A square. Square units. Let's look at one more example where we have to show that these 4 points are the vertices of a rectangle. Now, before we can show whether it is a rectangle or not, we need to know the properties of a rectangle. So, as we have already seen, the properties of rectangle are opposite sides are parallel and equal, and the diagonals are also equal. So, taking these points to be A, B, C, D, we get this kind of arrangement. So from here, AB is equal to this using the formula of distance, DC equals this, AD equals this, BC equals to this, and thus we find that AB equals DC and AD equals BC. So we can say that the opposite sides are equal. Now, just because the opposite sides are equal, we cannot consider this to be a rectangle. Why? Because it may very well be a parallelogram. Because even in parallelogram, we have opposite sides to be equal. But what differs the parallelogram and a rectangle are the diagonals. In a parallelogram, the diagonals are not equal. So let us also find the diagonals. Now, AC is equal to this, BD is equal to this. AC and BD are the diagonals. You can look at the figure on the left hand side of the screen. So we get AC equals BD. Thus, the diagonals are also equal. Now we can surely say that this is a rectangle. Now, we also have to find the area. So area of the rectangle is given by length into breadth. So this is my length, this is my breadth. So if you multiply this, you get 40 square units. So this question was as simple as that. Please practice as many questions as possible from this topic, and if you have any questions, please drop it in the comment box. Thank you everyone for listening. I hope to see you in my next video. Take care everyone.